So the idea is that we will have the National Maritime College at this point. The site here will house our new research facility, 1,500 square meter building, and the rest of the site then will be used as a technology park to allow companies to establish there and to really take the support from the research and development going on in the research buildings and the simulations available in the Maritime College. So it's really to act as a technology development area and to support the development of this ocean energy industry. So in our own research centre, we're rather fortunate. The government has made a commitment to the ocean energy research, and we have funding from the government for the Ocean Energy Research Group, which consists of 4 contracts for researchers until 2014. That's a long-term contract. Dara, who's talking to you today, is one of those senior researchers who has this long-term contract to allow us to develop the groups and provide this long-term support for the industry. As I say, my own research centre, then we have these wave tank facilities. We have a wave basin, which is 25 meters long, 18 meters wide, and 1 meter deep, with the 40 wave paddles along one side. We have a wave flume, which is 27 meters long and 3 meters wide, and that is used much more for fundamental work and teaching. In the new location, we're building what I call the survival wave flume. And it's a wave flume where you will be able to simulate at 50th scale the significant wave heights of 16 and 18 meters. And that is quite unique in the world, I think, where you have wave flumes. We will have a variable depth to the wave flume from around 0 to about 3.5 meters. The length of the flume is 35 meters, 12 meters wide. And this variable water depth means that we can simulate different locations with water depths in scale at 1 to 50, and then produce in that extreme waves to simulate survival conditions. And as I say, I think that's a unique situation in the world. We'll be able to produce up to 1 meter waves, 1 meter real waves, that is 2.7 seconds in this wave tank with the 2.5 meter deep wave candle. So I think that facility will be available and commissioned in 2013, and that will be quite a unique facility we have in our new research centre. Also in the research centre we have the group which Dara is heading up, which is working more and more now on the electromechanical problems of converting the energy from the wave energy devices and tidal energy devices into electricity. And we have a rotating test rig there, 26 kilowatt test rig, which is grid connected, and it allows us with the motor that we have, with a motor which you can control in any way you like, to simulate the variations in the torque or the power coming from the wave energy device or the tidal energy device. That then feeds into the generator, which then can be controlled with the PLC controllers to provide electricity which is suitable for feeding into the grid. So this is a very useful simulation rig which exists at the centre, which has been used then for simulating variable input power into the generator from either offshore wind, wave energy or tidal energy. Darryl just mentioned this in his talk about the Forest project. So the final thing that we're doing in Ireland then is, as I say, we have the lab test facilities which are developing with the quarter-scale test site. The final thing is the offshore test site which we're developing in the northwest side of Ireland. This is this location up here in the northwest, which is called Belmullet. And at the Belmullet site, we're going to provide 10 megawatts of grid connections with cables coming out from the shore. There will be 2 cables running out to a depth of 50 meters. So this is this location here, which is very close to the shore. It's about less than 2 kilometers from the shore, I think. This is we'll have 2 cables, 5 megawatts, and then the second set of berths will be out here with 100 meters of water depth. And they also will have 2 cables for testing in real sea conditions at up to 5 megawatts again. So this is our what we call the extreme sea open test site. And again, as I say, that is subject to the complete conditions that I showed you from the scatter diagram. And it's quite a severe condition because you really would not want to put a machine here until you're very sure that it's capable of surviving and operating in these extreme conditions, because servicing these machines at this location is going to be very difficult. The wave heights are less than 1 meter for only 2% of the year. So if you look at that, you're talking about maybe 100 hours, 150 hours in the year, that the waves are less than 1 meter. And you really need waves less than that to be able to access most of these devices. So that's quite a severe test site. And it really is that if machines can survive there, then you can be very confident that they are fully commercial machines which will operate anywhere in the world. So the conclusion then is that the wave energy really has a very large potential as a source of energy for Ireland in terms of contributing and reducing our importation problems. And the wave energy development in Ireland is proceeding to the strategy that we set out back in 2005. We're delayed maybe by 1 or 2 years, but it's not too critical. The delays primarily are coming because of financial investment issues. We have 2 wave energy developers which are at a very advanced stage of development, and we expect to progress to the next phase with megawatt machines offshore in 2011-2012. And in 2015 we have a European project called NER 300. Project called Westway, which will be funded by the European Commission through a scheme of carbon credits, which is being offered to renewable energy projects. So we expect that to use the commercial machines in 2015. So we think that we will really achieve our set targets by maybe 2021, 22, that sort of time, the 500 megawatts installed. So we're very confident that will happen, and we're also very confident that we will create jobs in a new industry which will really help us in Ireland to overcome some of this economic crisis we have at the moment. So really that's the situation in Ireland, and I thank you for your attention and hope it was of some interest to you. Thank you.
Any comments? Then I have one. Okay, I'm not quite sure whether this question is the correct question or not. Is it better to have wind sea or swell to generate this type of wave system?
I think it doesn't really matter, because in the west coast of Ireland we have a mixture. But one of the issues is that if you do have mixed seas, you can have a situation where you have 2 dominant wave periods. These might not be suitable for the machine. So you have to be very careful in interpreting the results. But fortunately in Ireland, when the waves are bigger than about 2 meters, we don't tend to find these mixed seas. We tend to find single peak in the spectrum for waves more than 2 meters. Below that you can get 2 peak spectra, which is wind and swell seas separately. And what you find then is that neither the wind sea nor the swell is suited to the predominant period of your wave energy device. Because most wave energy devices, you probably know, are narrow banded. There's only a limited range of wave periods where they respond very well.
Okay, that's it.
afternoon, everybody, and I'd just like to thank you all as well for such a big crowd to come and listen to myself and Tony and to Professor Tyke for organising this at rather short notice, so thank you very much. I'm going to speak a little bit more detail about the project that Tony mentioned, the CORES project, and I'm going to focus on some of the lessons we learned from this project, and particularly in terms of the components in ocean renewable energy systems, because this was what the focus of this project was about. It was not specifically to do with the performance of the energy device or anything of that nature, specifically looking at components in a wave energy device and critical components. What are the components that need extra attention? What are the components that can be critical in the failure path? That was the focus. So that's really the angle I'm going to be taking in this talk. Just to give you a little bit of background on this project, I know Tony already gave some background, but it was a FP7 project running from 2008 to this year. It's still running, not quite completed. It brought together a large number of partners from around Europe, research institutes, and also companies. And as I was saying, the aim of the project was to develop new concepts and to look at the performance of existing components for power takeoff, control, the moorings, and all of the instrumentation really for a floating wave energy device. And to do this, we used the platform of this floating oscillating water column, the OE Boy, that you've already seen. And there was also a whole range of modeling work that was done on this project. So during the course of the project, we focused on different aspects of the device. I suppose one of the main components that was being looked at was the air turbine. This obviously is the main power takeoff component. The device itself was given. We weren't changing the actual wave energy device part. So looking really from the power takeoff, the air turbine was the main component. Then obviously the electrical and the controls, and the moorings, the risers, the umbilical, grid connection, even though the device itself is not grid connected, but we can simulate some grid connection umbilicals in the wave basin, and also the whole deployment experience. What's the best practice for deployment? What are the issues in terms of deployment and testing in the field? So you've seen this picture before. This was the quarter scale platform. It had been tested over a couple of years prior to this in the company's own testing in the Galway Bay quarter scale test site, and it was just on land since the previous test in 2008-2009. It had been taken out and was completely rekitted then for the course.